All right, so we're going to do some notes on periodic table and the elements. So that's the title. Periodic table and elements. Okay. So first off, we're going to talk about the organization. The periodic table is not just a random collection of squares with element information. It's organized in a very specific way. And so we're going to talk about that for a little bit. So organization. Okay. The person who first organized the periodic table and is credited with its design is Dmitry Mendeleev, okay, Russian guy. Dmitry Mendeleev. Dmitry Mendeleev created the first periodic table organized by properties. Created the first periodic table organized by properties. Dmitry Mendeleev created the first periodic table organized by properties. All right, sorry, I just had to grab a new marker. Okay, so now we're going to talk about the arrangement of the elements. Oh, forgot a mark. Arrangement of elements. So we've got rows and columns on our periodic table. Okay, rows are sideways, columns are up and down. Okay, and we have different names for these for our periodic table. Rows, side to side, rows are actually called periods. Periods, okay? So that's why we call it the periodic table. Things repeat periodically, okay? And columns, which are up and down, are called groups. Elements in the same group have similar properties. Elements in the same group have similar properties, okay? So, for example, if you look at that first column, very left side of the periodic table, those are our alkali metals. And all of those, when you drop them in water, they burst into flames or explode, okay? So they have similar properties. Hydrogen way at the top of that group is not really part of that group for property purposes, but all the rest of the elements in there are the alkali metals. And we're going to learn about that in a couple of assignments. Okay. Then we have some organization as far as areas of the table go, and that's going to be our metals, our non-metals, and our metalloids. Metals, non-metals, and metalloids. And we're going to kind of make a little table here to tell us where these are and what their properties are, okay? So metals are to the left of the stair-step line. Are to the left of the stair-step line. If you look at our periodic table here, we've got this stair-step line. Metals are on the left side of the stair-step line, okay? So almost every element, including these ones down here, these are to the left because these actually insert right here where this bold line is, these all go right here and split the table up even further, okay? But all of these are metals. Okay? Exception would be hydrogen. That's a gas, it's not a metal. But left of the stair-step line, we've got metals, okay? And their properties, their defining property is they are good conductors of electricity. Good conductors of electricity. All metals are good conductors of electricity. Okay. All right, non-metals are to the right of the stair-step line. I'm going to abbreviate that SS, right of the stair-step line, and these are poor conductors of electricity. And again, we know that hydrogen is way over on the left side in the upper corner, but it's an exception. It's a non-metal, it doesn't conduct electricity, it's a gas, okay? But all of the other ones on the left of the stair-step line are going to be our metals, okay? And then finally, we have a word maybe that you haven't seen before, and that's metalloids. Metalloids share a border with the stair-step line, Okay. And these ones, we sometimes call these semiconductors, but they can conduct under certain conditions. They can conduct under certain conditions. Okay, I'm going to go over here and we're going to, so we talked about arrangement of atoms. Now I'm going to do a similar bullet and we're going to talk about atoms and their pieces. Atoms and their pieces, okay? Each element has unique atoms made of, each element has unique atoms made of, and we're going to do another table kind of like this one. They're made of protons, neutrons, and electrons. Now we're going to talk about each of those, okay? So we're going to talk about their symbol. We're going to talk about how to determine the number of each. How to determine the number of each. How to determine, okay? And we're going to talk about their location in the atom. Okay? Atoms are super, super, super tiny, but they still have pieces, and where those pieces are located in the atom is what this last piece is, okay? So the symbol for a proton is P+, and that plus is kind of a superscript, like an exponent would be, okay? So P+, lowercase p with a plus sign, okay? Neutrons are a lowercase n with a 0 as a superscript. And electrons are a lowercase e with a negative as a superscript, okay? So we're going to be talking a lot about these throughout the year, but protons are positive, neutrons are neutral, electrons are negative, and that's why we give them those superscripts, okay? All right, as far as their how to determine the number of each one. For protons, it's the atomic number. The atomic number. So if we're looking at our periodic table, okay, our Plainsman periodic table, when you have it in color, is going to have a green number in the upper left-hand corner of each element. So for sodium here, that number is 11. So it has 11 protons because of that green number right there. So that atomic number. If you ever forget which one the atomic number is, there's always a key on a periodic table that tells you the atomic number is right there, okay? So whatever that atomic number is, that's how many protons the atoms of that element are going to have, okay? And for neutrons, it is the mass number minus the atomic number. Mass number minus the atomic number, okay? So slightly different here. We'll just keep looking at sodium here. There is a mass number right there. That's 23.0. We always have to round that to a whole number. This one already is, but for magnesium, we would have to round that to a whole number. So 24.3 would round down to 24, okay? But for sodium, we've got 23, and that's what the whole atom weighs. 11 of the 23 AMUs is the unit for mass for an atom, come from the protons. So we have to take those 11 protons out, so 23 minus 11, and we end up with 12. So sodium has 12 neutrons, okay? Only the protons and the neutrons have mass. Electrons have a teeny bit of mass, and it's so small that we can just say they don't have any mass. So the mass number is just the protons plus the neutrons. So we subtract those protons out and we get the neutrons, okay? So mass number minus atomic number. Now, how do we figure out number of electrons? It is also the atomic number. Everything in nature likes to stay neutral, okay? So if we've got 11 positive protons in sodium, we're also going to have 11 negative electrons in sodium to make its atoms neutral, okay? Atoms are neutral, they don't have a charge. So these two have to balance each other because of their opposite charges. Whereas these two are the ones that have mass, so when you add the number of these together, you get the mass of the atom, okay? All right, finally, our locations. Protons are in the nucleus of the atom. Neutrons are in the nucleus of the atom. Okay, so that makes up the nucleus, just the protons and the neutrons. Okay, and our electrons are in layers around the nucleus. Our electrons are in layers around the nucleus. Okay. We're going to talk a little bit more about layers at the bottom of these notes, so just pay attention to that because you're going to need it for an activity, okay? But how many layers an atom has, I'm going to show you how to figure that out as we get to the end of these notes, okay? All right, finally, we've got arrangement of elements, atoms and their pieces, and we're going to go differences between elements. Differences between elements, okay? So, obviously, atoms, because of what I just showed you up here, have different proton, neutron, and electron counts. Different numbers of protons, neutrons, and electrons. Depends on the element that you're talking about. Okay? They have different properties. They have different properties. Now we're going to talk about different ways to categorize properties, okay? And they have different properties. When we say this, we're talking about intensive properties. Intensive properties, which depend on the type of substance. Depend on the type of substance. So if you change the element, you change its intensive properties. Things like color, boiling point, luster, how shiny it is, okay? Those things are going to be different. Their reactivity is going to be different because they are different substances. Okay? All right, there are also two ways to split properties, physical properties versus chemical properties. And these definitions are going to be important, so make sure that you get these down for your test. Physical properties are going to be, I'm going to just give you some examples. Color, melting point, density, etc. We're going to do a lot more with this later, just a little introduction. These are things that I can measure about it without actually changing the substance. So I can measure its color just by looking at it, and that it's still the same substance afterwards. If I melt it, like if I melt an ice cube, it's still H2O. I haven't changed it into something new. I could refreeze it fairly easily. Density, I just measure its mass, I measure its volume, calculate its density, and I haven't actually changed the substance. Okay. All right, chemical properties. Can also be different, okay, or will also be different when we're talking about different elements. And this would be things like flammability. How many M's are there? I feel like there should be a second M there, but I'm a science teacher, not a speller, okay? So flammability and corrosiveness. Other types of reactivities, whether it's going to rust or not. Strength, well, strength might be more of a physical property, but chemical properties are going to be things that when you test them, afterwards you have a different substance. So if I test the paper flammability here, if I light this on fire, it's not going to be the same substance afterwards. I'm literally going to be breaking that paper apart and turning it into gases as it burns. Okay, so flammability is a chemical property because it's changing the substance when I observe it. Okay, and then the last piece is those electron layers again. Okay, so different numbers of electron layers. Different numbers of electron layers. Okay, and this is how you figure it out. The row number in the periodic table tells you the number of electron layers. The row number in the periodic table tells you the number of electron layers. So, real quick example, if we are looking at our periodic table, I'm going to zoom this in here. In row 1, that's the very top of the periodic table, hydrogen and helium are both in row 1. So those are the only two atoms in this entire periodic table that have one electron layer, okay? But lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, those are all in row 2. So they all have 2 layers. Now be careful when you're looking at something like carbon, it looks like it's in the first row because it's at the top of its column. But row 1, remember, is this row right here, helium and hydrogen. So you have to make sure that you count all rows when you're trying to figure out number of layers. So down here, if we pick osmium, okay, it's not in the 3rd row. It's in the 6th row because there's 1, 2, 3, 4, 5, 6 is where we find osmium. So it has 6 layers of electrons, okay? So row number is number of electrons. And I just want to remind you, rows, hydrogen and helium are in row 1. So they have 1 layer of electrons. 1 layer of electrons, okay? So that does it for these notes, and we'll get to our next assignment.